Hello everyone, my name is Vrajkumar Maheshbhai Patel, and this proposal presents the design and implementation plan for a microservice-based warehouse management system. This project mainly focuses on the scalability, service isolation, and distributed system reliability using the modern cloud-native development practice. My project title is Design and Implementations of Microservice-Based Warehouse Management Systems. So this project focus on building a scalable and a fault-tolerant warehouse, warehouse management system using microservice architecture instead of a traditional monolithic design. In this presentation, I will explain the background and the problem statements, project objective, technical architecture, success criteria, project plan, risks and constraint, and the overall flexibility of the project. The goal of this proposal is to demonstrate that the project is realistic and as well as technically achievable within the semester timeline and meaningful as an applied computing capstone. Let's go to the point one, background and a problem statement. So the modern warehouse and supply chain operations depend on software systems for inventory tracking and shipment coordinations and order processing. So mainly traditional warehouse management systems are built using the monolithic architecture. So in a monolithic system, all functions are combined into one large applications. So the problem with this approach is that as the system grows, the maintenance becomes difficult, development takes longer, scalability become limited, and a failure in one module can affect the entire application. So today, many organizations are moving towards the cloud native and distributed architecture because they provide the better flexibility and reliability. So to address these limitations, my project proposal a microservice-based warehouse management system where each major functions operations as an independent services. So instead of one large applications, the system will contain separate services and separate services for each processing as of like the inventory, order, shipment tracking, and user authentications. So this service will communicate using REST API, and this approach improve the scalability, service isolations, and maintainability and the system reliance. Let's go to the point number two. Project objective. So the primary project objectives of is to design and develop a working prototype of a distributed warehouse management system using microservice architecture. So the specific objectives includes are first to the design independence microservice for inventory management, order management, shipment tracking, and user authentication. Second, to implement the RESTful APIs for communication between the services. Third, to deploy service using the Docker containerization. The fourth one is to develop an API gateway for centralized request routing. Fifth is to use the separate database for service isolations. And finally, to evaluate the system performance using scalability and fault tolerance metrics. Demonstrate the advantage of the microservice architecture over the monolithic design approach. Let's go to the slide 4. Point number 4 is intended artifact. So the final artifact of this project will be fully functional prototype of a warehouse management system. This prototype include an inventory management services and order management services, shipment tracking services, user authenticator service, and API gateway, Dockerized development, database integrations, and API documentations. In addition, the project will also include the test result, performance evaluation reports, and architecture documentation. The focus of the project is not only on building the software but also evaluating its scalability development, reliability, and fault isolation capabilities. Coming to the point five is a technical approach and MACP framing. So this project will follow the MACP framework, which stands for Machine, Architecture, Computational, and API layers. So starting with the machine layer, the development environment will use a personal workstation with the Docker support and internet access. The tool used include like Visual Studio, GitHub, Docker Desktop, Postman, JMeter, Draw.io. Next is the architecture layer. So the system will follow a microservice architecture where all services operate independently and communicate through REST API. Uh, Next is the system architecture diagram. So it's just basically show the overall overview of the architecture, which you can review it, but it's good. And the little bit just of the architecture layer. So the system will follow microservice architecture where all services operate independently and communicate through REST API. Coming to the architecture component, let's talk about the architecture a little bit. The architecture contains the API gateway, inventory service, order service, shipment service, user authentication service, and independent database for each services. The architecture goals are to loose coupling, independent development, fault isolation, horizontal scalability, and service maintainability. For the computational layer, the project focused on distributed applications developed and services architecture. So the proposed technologies, the main technologies are Spring Boot, REST API, MySQL, MongoDB, Docker, Postman, and JMeter, and the GitHub. So I have just left some specific version of the model because right now I'm just trying and practicing on it. So that's why I just mentioned it over there. The Spring Boot was selected because it provides strong support for enterprise level microservice development, and Dockers help maintaining development consistency and simplifying the scalability testing. Finally, the API layer is used for the RESTful APIs for communicating between the services, and all selected APIs and the frameworks are publicly available and do not require license restrictions. Coming to the point C is success criteria and the evaluation metric. One of the most important part of this proposal is the measurable success criteria. Instead of saying only build a system, this project defines clear evaluation target. So the system will be evaluated based on the API response time, system throughputs, availabilities, development reliabilities, fault isolation, scalabilities, and the usability. The specific targets include the average API response time below 500 milliseconds, supports for at least 100 concurrent requests, Also the 95% uptime during testings, as well as the 95% successful API request completions. So another important success criteria is fault isolations, where this means if one service fails, the entire system should continue operating instead of crashing completely. Also, the system will also be evaluated using load testings through JMatters to compare the performance against traditional monolithic architecture systems. Coming to the next point, scope definitions. So, in a scope features where to keep the project realistic within the 14-week timeline, the scope is carefully controlled. So, the in-scope feature include inventory management, order management, shipment tracking, authenticating RESTful APIs, Docker containerizations, API gateways, database integrations, and performance testing. Several features are internet, um, initially out of the scope, which is this includes such as the ERP integrations, IoT sensor, blockchain functionality, AI demand forecasting, subnets developments, and the mobile application development. Defining out of scope items is important because it prevents scope explanation and help maintaining the project flexibilities. Coming to the next point, assumptions. So this project includes several assumptions and constraints. The assumption include simultaneous warehouse dataset which will be sufficient, Docker will operate correctly, internet access will be remain available, and open source tool will be remain accessible. The major constraints are the 14-week timeline, limited hardware resources, lack of enterprise warehouse data, and limited development budget. The several projects risks were also identified. One risk is Docker configurations issue, which is another risk is service communication failure between microservice. This is also a risk related to the time management and the scope explanations. Also, to reduce the risks, mitigations strategy were defined. For example, uh, early environment steps, increasing testing, the incremental testing, weekly milestone tracking, authenticating and validating testings, and strict scope boundaries. So, ethics and privacy were also considered. This project does not only use sensitive enterprise data or personal user information, all dataset will be stimulated and security measure included user authenticator, secure password handling, request validations, and control service access. Talking about the dependency order, so the project development follow the structure dependency order. The first step is environment step including Docker, Spring Boot, MySQL, MongoDB, and development tools. After the environment setup, the database configuration will be completed. Then the user authenticator service will be developed first because secure access is required for the entire platform. Next come to the inventory management service where thereafter all service are operational, the API gateway will be integrated for centralization request routing. The Docker containerizations are integrated, testing will follow, and finally, the performance testing using the JMeter and project documentation will be completed. So coming to the point, uh, comparison baseline and the stakeholder acceptation criteria. So the project proposed microservice systems against a traditional monolithic warehouse management system. The comparisons focus on the scalability, development, efficiency, fault tolerance, maintainability, and system reliability. So, in a monolithic architecture, all the modules are tightly connected. Means updating or scaling one component often require redeploying the entire applications. In contrast, microservice which allows the independent development and scaling of the service. The project also defined the stakeholder acceptation criteria, where from the academic perspective, the project must demonstrate proper software engineering and distributed system principle, where from the system administration perspective, all Docker service must deployed and remain operational, and from the development perspective, API must be remain independent, testable, and properly documented. Coming to the, I have also talked some of the ethic, privacy, and security considerations where this project does not use sensitive personal or enterprise warehouse data. Also, all data set will be simultaneously to avoid privacy concerns. Security consideration include user authentication, API request validation, and secure password handling, control service access. Coming to the project plans and the milestones. So the project plans is divided across 14 weeks. The early weeks focus on the project approval, architecture design, and environmental setup. The middle phase focus on building the individual services such as inventory, order, shipment, and authentication. Later week focus on the API gateway integrations, database integration, system testing, performance evaluation, documentations, and final presentation and preparation. The work breakdown structure divide the project into six phases: planning, environmental setup, service development, integrations, and testing evaluations, and the documentations of it. So these structures help the maintaining organizations and ensure every task connect directly to successful criteria. I have also supervised the integrations where the proposal has been revised based on the feedback received from the assignment one, where I have added the measurable techniques, successful criteria, and evaluation metrics, defining the explicit project scopes and the out of the scope boundaries, or as well as I have added an AI user log and academic integrity statement. Right. Also, brief project summary where this proposal presents technical uh, technical flexibility and well-structured Capstone project focus on building a microservice-based warehouse management system. So the project address the real-world problem found in the traditional monolithic warehouse system, improving scalability, maintainability, reliability, and the development flexibility. Also, the proposal include the measures success criteria, while realistic milestones, the risk management strategy, technical flexibility, and structure implementation plan. So, by the end of the project proposal, it will be demonstrate the practical application of the distributed system software and the software engineering principle and the containerization. As I said, I have also add the AI usage log. And thank you for watching my presentation.